Welcome to this video all about averages from frequency tables. You can find the PDFs with questions, clues and fully worked solutions on mathsupgrade.co.uk. This first question is a non-calculated question and the remainder questions are all calculated questions. For 3 marks we need to work out the mean number of lates per student from this table. So this is known as a frequency table. What this tells us is that we've got 15 zeros, 8 ones, 3 twos, 3 threes and 1 4. Rather than writing out the numbers as a list, you can just find the sum of each group here. Since I've got 15 zeros, that means that all of these zeros must add up to 0. So I can just do 0 times 15, which equals 0. Since I've got 8 ones, rather than doing 1 add 1 add 1, I can just do 8 times 1, which is 8. Similarly, I can do 2 times 3, which is 6, 3 times 3, which is 9, and 1 times 4, which is 4. So now the total of that data is 27, and I know that I've got 30 numbers in total, since the total of the frequency is 30. So to find the mean, it's always the total of the values divided by the number of values. So the total of values is 27, the number of values is 30, so if I do 27 divided by 30, I can just simplify that fraction, dividing by 3 on the top and bottom. That gives me 9 over 10, which is 0.9 as a decimal. So the mean number of lates is 0.9 as a decimal, and that's 3 marks for that. In question 2, Deborah recorded the favourite colour of each of the 30 students in her class. The incomplete table shows some information about her results. We need to complete the table for Deborah's results. First of all, we know that there's 30 students in the class, and so all these numbers here must add up to 30. So the missing number must be 30, subtract all these other numbers, which gives us 2. For the second mark in this question, we're asked the modal colour. The modal colour is the same as just the mode. It's the category with the highest frequency. The category here with the highest frequency is blue, since blue's got the highest frequency here as 10. So the answer isn't 10, the answer is the category name, which is blue. And that's another mark, so that's 2 marks for that question. In question 3, we're given some information about the dress sizes of 25 women. We need to find the median dress size first of all. The median dress size, we need to first of all find the middle position. The middle position in a set of numbers is given by the number of numbers, add 1, divided by 2. That gives us the middle position. Once we've got the middle position, once we know where that is, we can find which group that is in. So, since there's 25 women, and obviously the total here is 25, n is 25, so 25 add 1 gives 26, divided by 2 is 13. So the 13th value is going to be the middle value. So where's the 13th value? You can either find it from the top or from the bottom. It gives you the same answer. So from the top, there's 2 values here. There's another 9 values here, so that's 11 values altogether. There's 8 values here, so the 13th value must be in this group here, From the bottom, we can do the same thing, just to confirm. There's 6 values here. Another 8 values gives you 14, so the 13th value must be in this group here. So the median dress size is this one here, which is 12. So dress size 12 is a median. In the next part of the question, we're told that 3 of the 25 women has a shoe size of 7. Zoe says that if you choose at random one of the 25 women, the probability that she has either a shoe size of 7 or a dress size of 14 is 9 over 25, since these 2 fractions add to give 9 over 25. Is she correct? This question involves probability. If you're not sure about probability, be sure to check out my video on this channel. The question here is, are they mutually exclusive? And they're not mutually exclusive. Since some of these 3 women who had a shoe size of 7 could also have a dress size of 14. This calculation is not true. It's not correct. These shoe sizes have got nothing to do with the dress sizes. They're not mutually exclusive. They're both, someone can have a shoe size of 7 and a dress size of 14. So this is what I've put here. Since some of the women may have both that shoe size and that dress size, they're not mutually exclusive. So she's incorrect. And that's 2 marks for that whole question. In question 4, we're given a table which shows information about the number of points scored by 30 students in a quiz. We need to find the modal number of points. The modal number of points is the category with the highest frequency. So think about which category's got the highest frequency here. This is the highest frequency, so the category must be 2, so it's 2 points. Now we need to work out the total number of points scored. The total number of points scored, well, these 4 people didn't score any points, so their total will be 0. These 3 people scored 1 point each, so their total is 3. These 7 people scored 2 points each, so their total is 14. So in essence, what I'm doing is I'm multiplying each number in this column by the corresponding number in this column. That gives the total of each group. Then to find the total frequency, just add up these numbers here, which gives you 81. So the total number of points scored is 81. That's 3 marks for that question. Question 5. Ross rolled an ordinary dice 30 times. The frequency table gives information about its results. So we need to work out why it's impossible for the mean score to be 8. So quite simply for this, you can see the scores here. So the greatest score represented in the table was a score of 6, and 4 people had a score of 6. So no one had a score higher than 6. That's why it's impossible for the mean score to be 8. So that's what I've put here. The highest score was 6, so the mean cannot be higher than 6. In the second part of the question, we're told that Graham also worked out the mean score, and here's his working. So we now need to work out the mistake that Graham made in his method to work out the mean score. So the mistake he made is given there. He should really have done 99 divided by 30, since 30 is the total frequency here. And you're told in the question as well, the dice is rolled 30 times. Instead, Graham has divided by 6. He's divided by the number of groups here. He should have divided by the total frequency. If he did 99 divided by 30, he would have got 3.3. And that whole question there was worth 2 marks. In question 6, I need to find the class interval that contains a median from the information about heights of 80 plants. So to find the median, that means you need to find the category containing the middle value. To find the middle position, I need to do n, which is the number of plants, add 1 divided by 2. Since the number of plants is 80, the total frequency is 80, you need to add 1 to 80 and divide by 2. That will give us the middle position. Then we need to find the category containing that middle value. So 80 plus 1 divided by 2 is 40.5. So we need to find the 40.5th value, either from the top or from the bottom. I'm going to do it from both just to show you. So there's 7 numbers here, another 13 values here, that's 20 values, another 14 values, that's 34 values. If I add another 12, that's more than 40.5, so the 40.5th value must be in this category here. Let's do that from the bottom to show you again. So 18 values here, add 16 is 34 values, 34 add 12 is 46, so the 40.5th value again must be in this category here. So that must be the middle value here. So the class interval, the category that contains a median, is 40 to 50. And that's what I've written down here as an inequality. I've just copied it from this column here. That's 1 mark for that question. In question 7, I'm given information about the times taken for 18 students to run a race. We need to find an estimate for the mean time. This table here is not a simple frequency table, it's known as a grouped frequency table. So the best I can do is find an estimate, since I don't know exactly the times run by these 18 students. I only know this one student ran time between 5 seconds and 10 seconds. So all I can do is assume this student ran a time at the middle of these 2 times. So I'll assume this student ran a time of 7.5 seconds. Similarly for these 2 students, I don't know what time they ran. I'm just going to assume they ran a time which is exactly in the middle of 10 and 15, so 12.5. So in other words, I'm finding the midpoint of each of these times. So the midpoint, once I've found the midpoint, I can multiply it by the frequency to give the frequency times midpoint. Then I can do the total of that column here, which is 335. Do 335 divided by the total frequency, by the 18 students. That gives us an estimate for the mean, which is 18.6 to 3 significant figures for 3 marks. Question 8 involves a bar chart as well as group frequencies. So Fran asks each of 40 students how many books they bought last year. The chart below shows information about the number of books bought by each of the 40 students. So you can see here, this group here had a frequency of 11, this group here had a frequency of 8, and so on and so forth. So what I can do, I can create a table which shows the number of books, 0 to 4, 5 to 9, etc., and the frequency, just reading off the heights of each bar. That gives me 11, 8, 13, 6 and 2. I know that there's 40 students in total represented by that data, and I can check that by adding the frequencies. That gives me 40. Now to find an estimate for the mean number of books, I can just find the midpoint of each group. So for this one it's 2, 7, etc. Then do frequency times midpoint, and then do the total of that column divided by the total frequency. That gives me 9.5 for 4 marks. That's the end of this booklet. If you struggle with any of these questions, be sure to check out how to find the mean, mode and median from the videos on my website, and be sure to check out the PDFs with the full work solutions. Thanks for watching.